Hello, hello. We're back um, for the last stream before the GDC comes over. And yeah, welcome. Alright, so I'm not gonna lose any time and I will jump straight into what we're doing. So we've got. So what did we do since the last time? So the first thing we did is that we've got actually we're gonna set it up now, but basically last time where can I put this? I'm gonna plug this up there. That should be good. There we go. All right, so basically so far what we've been working on is a game that was mainly, no, you mainly saw it as just me playing it. So but a big portion of how the game gets played is by the fact that it's co-op. The fact that it's co-op. So that means that this is the first thing we worked on since the last stream. Specifically, you can now. Oh, that guy is a little sick. You can now hold F, and that will, spawn a character. And if you hold on another device, you'll also spawn another character that you'll be able to play around with. And both of them you can move around independently, you know, do the same thing. So this is the first thing we did. Another thing, so we kind of another thing we did is that we polished the throwing mechanics a little bit. So I forgot to link, so we're gonna do that before I continue showing the rest. But I forgot to link in the player actions a bunch of the actions for gamepads. So you see like all these guys don't have anything. So we've got, for the crouch, we're going to add a binding that is going to be the left stick press. Left stick press. Yeah, left stick press. So we're gonna do this. Then on the grab, this grab function here, add binding is going to be, I think for grab we wanted it to be triangle, the north button. No, grab was the trigger, sorry. So grab is the right trigger. That's more like the drag feature. The interaction button is the triangle, so button north. The throw button is going to be a square. And then we'll have, oh shit. And I did it here too. Add binding and add binding. So here we said the throw was going to be square and the triangle was going to be for interactions. So this is what we got. This one we don't really need, and we're going to add another one a little bit later on that's going to be like this slapping on the back button, so that you can essentially do a close, you know, slap to disorient the player and potentially some monsters. So now I'm going to continue showing it with the controller and going to test how it feels with the controller as well, because it's a pretty... I'd like to think this game will be more focused on console, just for, you know, just because it just feels better to play it on this with a joystick. The one thing that's a little weird is it's not very smooth, the movement. It's kind of like you go that way and then that way. It's like you can't really like turn in circles smoothly, but anyway, we'll fix that later. So you interact, you jump over this, you pick this up. Why can I not pick it up? That's an interesting problem that starts off the stream. Why can't I pick up my thing with the controller anymore? And I can pick it up with this, I suppose, hopefully. So if I return... Huh. Why can't I pick things up anymore? You know what? Because it's supposed to be range, I think. Oh boy. Ugh. Oh no. So I modified some scripts, I think yesterday or something, and for some reason a lot of them got disconnected off of what they should be, because Unity. But the grabbable objects are up here, and that should just make it work better now, essentially. I'm just a little surprised why it did it like that. You know? It's annoying, but better it happens now than a little bit later. And then the game manager, this thing here seems a little offset on that side. Negative 25. All right. Okay. So that should be a lot better now. We're gonna load up, open this lever, jump over there. We're gonna also want to check the stats just to make sure it's only running at 40 FPS. So I'm not exactly sure what it's doing to be so slow. I have a feeling it's probably this guy here that's slowing stuff. 40 FPS. Gonna have to do some optimization. But so you pick this up, and then you're gonna be able to kind of just aim where you want to throw it. and kind of see how it's gonna bounce up. It's still very raw, but this is kind of like one of the first thing to simulate. It's the very easy way of like simulating how it's gonna interact and react. Then the other one we did is this bridge here, where you need basically you can't cross it without a friend. Alright, so it's part of like some certain puzzles will require you to work together, and it's essentially just like this one is really simple, just to demonstrate how it works, and mainly also test it. Fun. Oh, I almost made it up. Almost made it up. No. Alright, I think it needs to be a little not as high. There we go. And now it, you know, essentially moves up. This moves back down, and the people can proceed. We've got also our little chop hammers that send us flying. Why can't I move anymore? This refuses to let me move. Why is that? State is blocked. Did it not reset the state correctly? Crouch, on jump, on interact, on throw, on grab. That's an interesting issue. Yeah, it still thinks the state is blocked, but curious why. Did it not call this up, face down? No, it didn't. Is it because it's on here? No, it didn't. So it's probably because face up. Let's figure out face, proper directions, velocity. Okay. Anyway, so we're gonna press X on here, load up. I'm gonna cheat. You know what? Because I'm not. I just want to do it quickly right now. Whoop. Doop. And doop. press play. All right, we're back here. Kind of figuring out. All right, and then we try to get up. And now we're back. Okay. And then we have this room here that lets you yeah, I think we need to remove a couple things here. But essentially what I am going to do is go here. I will be removing this and this here. Like that. I'm actually going to delete them so that they're never instantiated or anything. The reason for that is because we want to shoot that way and rotate this thing later on. But if we do so, like you get caught into the railing because you're ragdoll, so your limbs may get caught in, so you may never basically reach it. So that should fix it essentially. And then the other thing that I was kind of wondering is, why is this guy so messed up? He wants to go, but also not go. So just check it out. So that's the AI controller. Calculate movements. Path to follow is no. So this is false. So velocity is 0.14 to 0.06 to 0.39. Okay. So here, just the only thing that I'm doing is, alright, so before I start, what I'm going to do today is that I'm going to make this skeleton work. So currently for this skeleton, we have a star graph that's like this, okay? This shows basically where the AI can walk and where they can't walk. Yeah, so that if they can join in the so like if the player comes over, how can they reach him, all that stuff. You see there's some step heights, all that good stuff. Then we've got our skeleton, which is essentially just a rigid body and a capsule collider. It does have the ragdoll kind of roughly set up for now. It's the same character movement controller as the player. It's essentially a little capsule that floats above the ground so that it's not impacted by friction, can climb up slopes and all that stuff. And so it rides at 0.75 above the ground. It has a force that keeps it upright, and then it has, you know, the basic ragdoll stuff, the animation to get up, how long it takes to regenerate back to its shape, and then some more specific AI movements. So the player controller from locomotion is a little bit more you know, like you can jump, you can hold jump, you can hold do all that stuff. The AI movement is like a speed, max acceleration, and acceleration in the air, and how far they consider they reach their waypoint when they're doing the pathfinding. And then for now, essentially, it's an AI that will look at the player and move towards the player and then stop when it reaches the player or is 0.5 away from the player. We'll expand on that later. What we'll expand on later is we'll use one of the state machine, very simple state machine, to give 3 states to our AI: the patrol state, the aggressive state, and the dead state. In the patrol state, it will have a bunch of points or a passive behavior, pretty much. So I think that's what we'll call it: passive, aggressive, and dead. The passive state will be kind of like a patrol or something like this. The aggressive state will be, you know, moving to the player and attacking. The dead state will be ragdoll, exploded on the ground. Some enemies will be able to move from the you know, dead state back into the passive and aggressive states, depending on, you know, like a skeleton will be able to weave her leg, come back up and then continue chasing you, but maybe like a, I don't know, like a crow will just get hit and then disappear later on or stuff like that. So we'll have a little bit of freedom to do this. But basically what we were seeing here is that it doesn't have a path, it doesn't add any force to the movement, and yet it still moves forward, up and down. So what I'm going to do when I calculate the movement is just like, if we don't have a path to follow and we don't have anywhere to go, we're just going to not go anywhere. Not going to have any force. And we do this by doing this, rigid body dot velocity dot y, so that we still have the spring working for us. We just want to negate the x and y and x and c velocity, essentially. I think you can technically do it like that. No, all right. So let's see if this works any better. Another thing we wanted to do, but we'll do it later, is this will change at some point. For now, we'll leave it like that. We'll make sure, so he doesn't move anymore, so that's, you know, improvements. However, he kind of twitches weirdly, in my opinion. And I think I'm not sure why that is the case, if I'm being very honest. Probably because will it come to stop at some point, or it oscillating between 0.45 and 0.5 weirdly? he always jumps. That's the weird thing, even without that. Like, he does do a weird jumping up and down. Could be because of this stuff. Fail. That's weird. Could it be the animator? Apply root motion? It shouldn't apply root motion, should it? No, it shouldn't. I think that was it. Yep. All right. This is a lot better and will now function a lot more predictably. I couldn't figure out why it was doing this thing, but now I do. So how much do we want it? He wants to be kind of 700 up in the air. How do we want it to fall? Do we want him to fall kind of? All right, 700 to 100. All right, that's much better. And he also doesn't move. If we add 1, we're gonna add 20% of the mass pretty much. So this is gonna be 0.12. Nope. 1.2. And same here. Same here. And same here. All right. So how is it looking now? He stops. He looks nice and like a nice little skeleton. And he's got his ragdoll all working for him. Okay, so we're kind of good here. Now we've got this. It's not when it's looking for a path, it's when it's not looking for a path. And when the path to follow is equal to no. Now let's see how he does. Look at that guy. Look at him fly over there. He's a little twitchy here, but I wonder what happens here. He is technically at the end of a path. I think it's because of the rotation more than anything else. Like the rotation still has a bunch of force in it. So what we'll do is we'll just reset velocity pretty much. No, we'll do m rotation equal transform dot forward And another thing that I wanted to see is exactly what is its range. So like if he is at 2 here, being at 1, nope, wrong one. Would make him pretty far. 0.5, 17, and 18. So that is essentially, I mean, maybe he needs to be like here when he's reached something. So 0.8. He'll need to be at 0.8. I also want to move him that way and not rotate it. So leaving it like that. And here is going to be 0.75. That's their reach, essentially. You hold, and he walks. And he doesn't twitch when he gets to the end. He just faces forward. Alright, so that's cool. The other thing I'm curious about is what happens if he's on something like that. Oh, right, he just killed himself. Okay. Alright, so right now, what we've got is an AI that can look for a path and then move to it. Check for spring trap, and also the hammer trap that is here is going to have to also trigger this this model. So that's this guy. Include layers, player, NPC, and monster. Yeah. Let's probably also include some props. And the limb. No, let's not do limb. Player prop. Alright, like that. So now that we have this you know, skeleton moving, we're gonna get rid of this. Look for path is going to be static. It's gonna take a seeker. No, sorry, it's gonna take an AI controller called AI, and it's also going to take a a vector 3 position. All right, it says an AI that goes to a certain position, essentially. So the first thing we're going to do when we look for a path is if AI dot looking for path return. Then what we're going to do is remove this and remove this. In here, we're going to do AI.seeker.startPath, and here is going to be AI.isLookingForPath becomes true. This is the AI rigid body. This is the position. And on path found, this is what you call. On path found, you're going to call AI.onPathFound. Like that. So this is a static function that it can be called from anywhere to look for a path for our AI. This is going to be kind of important later on. I think we're also going to want to make this into a static function as well. We are going to want to make a public bool looking for path that returns m is looking for path, a public and then a public, what do you say? Seeker. This is not going to be modified, mSeeker. And the looking for path here is going to just be a get set function, like get protected set, I think. All right, and the other thing that I kind of was hoping, it's okay, we'll just leave it like that. And then here also public static at end of path. We're gonna take a ref int current waypoint, as well as a path to follow. Path to follow, and we also want the transform, but that's going to be the AI controller AI. So is the AI at the end of their path, and they're currently at this thing. So the AI dot rigid body dot position, the path to follow, their current waypoint, current waypoint, path to follow, and here is going to have to be another thing that we're going to call, how are we going to call this one? Public reached waypoint distance. It's just going to be just m dot reach waypoint distance. That. Then we're going to set that here. And that should be good. Okay. So that's that. Then we have our simple state machine. We initiate it here. And we're going to go do it in its own function. So this is going to be region locomotion path a star movements and region. And now this is going to be our state machine brain region. So first up, protected, virtual, build brain. That sounds cooler. Build brain. This is going to become mbrain. So the brain is going to be a simple state machine. Mbrain dot. Then we want to set states and add transition, get current state, and all that stuff, and tick. Trying to think a little bit about how we're going to do this. Essentially, I have it in my while you're in taught stuff here. Just for a recap, essentially we want to build states first, and then a transition between those states, and those states are also state machines. Like this passive routine here is an I state that is got a state machine, an agent. Okay. So this here is that basically it says tick as in, you know, like do a step of the state machine. The state machine is here, build brain. And so it's going to have, as we said, 3 states. It's going to have passive, aggressive, and dead. Those states are going to be for pretty much every AI that we care about. I know it's weird to put the variables not at the top of the file, but I'm the only dev on this project right now, and it makes it simpler for me to have just region that have the whole thing I need in it. That way I can, like, you know, close it and put it back. And those awake functions are just, you know, the stuff that needs to be done anyway. So that way I can, you know, have a scope that I can work on. And I know it's a little weird, but I kind of just enjoy doing it like that. Oh, when my dog woke up. So a state machine is going to take first off a few default states. Keep looking at my dog because she's being on the bed and it's being very cute right now. She's trying to make a bed. Posy, don't shred the fabric. It's very cute. So AI controller, and then we need a bunch of states for the state machine. And in those states, we're going to have the brain states, but it's also called like how can I call that? Well, for now we'll just do the passive states. This is a patrol, so yeah, patrol state, is that how it's called? Patrol routine. Then we're gonna have the let's do a patrol routine, an attack player state. And let's do a dead state. So those two, I'm differentiating between state and routine. The routines are going to be themselves nested state machines. The state is just going to do one thing and wait for another thing to happen pretty much. This is now going to have a bunch of steps it needs to go through, but these will have, you know, a bunch of steps and logics that it can do. So this, we're going to call it the basic attack routine. Because we might want to do a skeleton attack routine for the like a skeleton boss attack routine, all those. So it takes an ice state. And in the ice states, we're going to implement all those missing members. So ice state is when you enter a state, right? So it does a couple things. A state will always have a function that is called when you enter the states, a function that is called when you exit the states, and tick is what the state machine calls when you call tick in the when we call tick in the AI controller, which is, where is the AI controller now? Did it just disappear? There it is. And then the AI controller, when you do mbrain.tick, it's gonna call this. It's also, maybe we'll look into our simple state machine AI. It's pretty simple. You have a bunch of empty transitions. You have, you know, a dictionary that has a list of every transition from you know, a type to somewhere connected transitions. These are the current transitions, meaning they point towards where you can go. Those are any transitions, so they are in addition to the current transitions. There's stuff that we're always going to look at. So think about like the animator, right? When you're in this state, these are the current transition, but if you have an any states transition to this, you'll have all three of these. So that's basically how the animator works and how this is thought of. So we have our transition not equal to null. We set this transition. So every time we do a tick, we're gonna do a get transition, which is gonna get us here. It's gonna look into all the any transition, and if it matches if one of the condition is true, then it's gonna return that transition, and then it's gonna look into current transition, do the same thing. A condition is a boolean, a function that returns a boolean. That's what we set at runtime based on the AI. Not at runtime. When we actually design each specific AI, we'll code what that function is. Then, you know, it gets which transition it should do. If it has a transition, then it's going to set that new state. When it sets a new state, it'll call on exit to the previous state that we're exiting. Then it's going to try to get the value, and if there's no issue, it's going to state the new state to this, and then it's going to call on enter to the new state. And if there is no transition, then we'll just do a tick on the current state, which just means, you know, a fixed, like an update or a fixed update or whatever. So the state that is kind of universal for everybody, I think, is going to be the dead states. And the dead state is basically going ragdoll, and then once it's ragdoll, maybe we'll want an animation, like a death animation that will like spawn a VFX, dematerialize the thing, whatever, right? As long as we have that option. So we'll probably do like a death somewhere in here that's not connected to anywhere, that we just call by doing play. So how do you do that? We're going to do mbrain dot var dead state is going to be equal to new dead state. This dead state is going to be an I state, like that, private, and then we're gonna put all those missing members here. Another thing we can do with your states is you create new functions. So like yeah, so basically you want to make sure that your state is linked to the correct AI, right? So for a dead state, what do we care about? Probably just the AI controller. We're gonna call it AI. And this is gonna be a private read-only AI controller AI. And we're gonna do a public, no, whatever, we don't need that. Then in here, we'll do private animator. In here, we'll do MAI is equal to AI, MAnimator is equal to AI dot whoa, that was a loud sound. Let's see. Yeah, the animator is here. So let's just do a public animator to access set animators. That way we don't have to reuse or get components. And that should help. Animator. But also we just don't need this now that we do that. So we'll leave it like that. So what happens when we enter this? Essentially, we are going to want to either go ragdoll and then play an animation, or go ragdoll and stay ragdoll, or go ragdoll or don't go ragdoll and just play the animation. Like maybe we'll want to just have a death animation. The animation is not going to be on exit. The animation is going to be... we're just going to make spawn out, which will play the animation and then destroy at the end, essentially. Let me just stop this notification There, that should get a little bit better. All right, and private. Oh, come on. Spawn out. Those animation on Discord, those sound effects on Discord, it was really loud, I find. But anyway, M trigger ragdoll and enter, ragdoll and enter. Then we'll go on our AI controller here and we'll put a little we'll put a little header, depth logic, serialized field, private bool, and it's gonna be ragdoll on death. It's gonna be true by default, and then we're gonna have to do serialized field, private bool, m destroy after ragdoll, which is going to be a false overall for now, and here we're going to be animate destroy basically, but we'll just leave it for now like this. Destroy after ragdoll. So this is going to now be this m ragdoll and enter, ragdoll and death, m destroy after ragdoll. Now that we have this on enter, here we're also going to add a float m rigid m last fail magnitude. Then if m last fail magnitude you know what, I'm gonna call this M agent because this is really annoying. M agent dot animator dot play the dead state. I already have a dead state. The hell? Don't think I. Oh, I think I technically do. Wait, is it in GetUp? No, it's GetUp start and GetUp dead. So we'll just create a states down there that we're gonna call dead, and that's just gonna be that for now. It's a state you do not recover from. And at the end of this animation, we'll probably do a destroy or animate close out or something. So play animation state functions and events will handle when to destroy object and how. Okay. So when you tick, you do all that stuff, and then when you enter, then your first off, your last velocity is going to be your agent.rigidbody.velocity.magnitude. It's not going to be 0, otherwise here is going to be 0. Then your if trigger ragdoll on enter is true, then we're going to do m last velocity agents dot switch ragdoll, wait, trigger ragdoll, false, on, true. Trigger ragdoll true, text is here, it changes the state of the ragdoll. I mean, yeah, should be good like that. And if we do an exit, so like, if this is called, then the last thing will be the exit. Oh shit. Oops. Sorry. If, you know, if we spawn it out, the last thing that we're gonna do is play the animation. One thing that I forgot here is that dot is name dead equal false. Just the one little thing that I missed here that is good to playing death animation. The nice thing here is that that I forgot is that if it is playing the death animation, we don't want to replay it all the time. So if it is playing the death animation, then we'll just say if not playing death animation, then you do it. But here, we're just gonna do trigger ragdoll back to false because this is only called for AIs who can come back from the dead. This is called when the AI starts dying. And this is called every fixed update. All right, so this is our death state. Okay, AI controller. Dead state. The one thing that we also need is kind of like an any transition, mbrain dot add any transition. So this will add a transition that goes from anywhere to our dead state. And the predicate is if the player should die. So if the state changes to dead, essentially. So here we are going to do one more thing that is called a public enum that's just going to be passive, aggressive, and dead. And then down there we'll do protected AI states, brain states, and if the brain states is equal to dead, this is going to transition to that. What am I doing wrong here? Doing that wrong. think you can just do that too. Yeah. So this will return true when the brain state is equal to dead, and when that is happening, then the dead state will transition. We're building the brain in our we're building the brain in our awake function, and then in our start function, we are going to set initial brain state. This is also, we're gonna make pretty much every function on this virtual in case we want to change it later. But the initial brain states, we actually don't really need to do a whole set initial state here. We'll just make it in start, right? We'll just do m states brain state equal m starting state, right? So that kind of will make sure that we do all the stuff we need to do. We create a state machine, and then once we're ready for it, you will set the default state of the state machine to whatever it is. However, it can't be done through this. I'm stupid. It has to be done through the simple state machine.set states, because it will call the current states, and it will actually also call the on enter and trigger that ragdoll if it needs to be triggered. So it is actually mbrain.set states to m starting. Sorry, no. We will do an initial state now, because there's something that I didn't realize that I just realized as I tried to explain something wrong. Void set initial state. You need to do one thing. M brain states is this, and then if the m brain state is equal to m to dead, then we will Alright, like that will get us to set our initial states based on some values that we have, this initial starting state here. So good way to test it is we are not going to spawn a character itself. What we're going to do is we're going to look at our player, our animator here. Down there, we're going to make sure he's passive and ragdoll and enter, destroy after ragdoll, So he is good. He does everything like he should. And dead. He start dead. Little weird, little bit of weird hands. He's got the weird hand syndrome. But that's a dead body right there. All right. Looking at this right now, I think I did something wrong with the way I did their... Yeah, see, they have hands. Definitely have those hands. So we will do the same here, meaning that the lower arm right is going... That's the player model. Nope, we don't need you. Rect transform, revert all, we don't care. This guy. This is who we need. So the left, we'll do the right clavicle first. Upper arm, lower arm, and hand. That's kind of where the issue is with those. They're pretty poorly set. It's gonna be kind of a smaller size arm and you know all that because it's just a skeleton. So we've got an upper arm here, a lower arm there. Nope. Oh, that's actually kind of nice. Lower arm is gonna go kind of like that, I think. Maybe a little bit bigger and a little bit thinner up here. All right, and then we'll have our hand, which will have our character joints, as well as our capsule collider. That's a big capsule collider. Just for sake of going faster, we'll do base component values here, and then we will just make it slightly bigger by pushing it on here, pushing it on there, pushing it over here, and pushing it over there. Now I also kind of want to push it down a little bit. Of course, it's a capsule, so the more I make it big, the more it goes bigger here too. All right, anyway. A character joint is going to be the lower arm here. And yeah. Okay, then we will copy this component, open this, open this, open this. Then we will paste this component, and then we will add a capsule collider that we will make the same as this one. Wait, which one did I pick? Copy component. No, yeah, copy component, and then paste component values. Must have done something weird before. And then instead of being all right, and then here instead of the lower arm left, it's the lower arm right. Okay, and then we go here. He's still on the dead state first. Let's see how he handles it. Oh no. Gotta fix this one too. Copy components. Paste component values. Copy components. Paste component values. Alright, now... Alright, it definitely reacts a little bit better. I also kind of like it feels... I like this. It just feels good, you know, like he's laying down and then he falls, and yeah. We are going to update when off screen because we are like that. I don't think we want to update it when it's off screen because it's just going to, if an accurate bounding volume representation should be calculated every frame. Yeah, probably. Okay. Alright, on this guy too, one thing that we need to add, it's going to be a special NPC variant kind of thing, where basically instead of the mesh renderers that are set here are going to be a variance of these essentially, so that every time you play the game it's going to be a little bit of a different skeleton. It's just to try. Sorry, this is not what I plan to do, but it's just so we can try having a little bit of a So the way we're going to do this is before the base awake up here, we're going to put a special header NPC look and we're going to call it serialized field private mesh renderer skinned mesh renderer. Randomize the randomize avatar. That's what we're going to call it. I'm going to call it randomize avatar. And this is going to be M potential avatar options. Avatar options. All right. It's going to look like that. Then in here, we'll do a private void set avatar. And we're going to say in the wake m mesh renderer if we don't want to randomize the avatar, then we're just going to return. Otherwise, int avatar index is going to be a random dot range between 0 and m avatar options dot length. Those are ints, so it's going to be between min exclusive and max exclusive. Then we're going to do our avatar to use is going to be m avatar options dot avatar index, and then m mesh renderer m the mesh renderer is private. They are. Oh, interesting. And mesh renderers is just going to be here, and it's going to be m mesh renderers equal new avatar to use. Just like that. It's going to override this, and then we'll do for each avatar let's do for int I equals 0, I under avatar options dot length I plus plus, if I equal avatar index activate equal I equal avatar index. Then we'll do m avatar options I dot game object dot set active activate use avatar and this is going to go before base awake, before, so that we override the presets with the potentially random avatar selection. Before the base function call, like that. All right. We're going to randomize the avatar. We're going to put this one in. We're going to put this one in. We're going to put this one in. And we're going to put this one in. And we're going to play. And it's a soldier now. All right, cool. Cool beans. Now a soldier. This is good and great and all that, but it's not really useful because that's pretty much this is how far the base AI controller will get us. Because we do want different enemy AI, we do want different boss AI that have different aggressive behaviors, we want different, all that stuff. The reason why we did it like that is so that it would be easy to add new enemy types. So essentially now what we're going to do is see how easy, granted this one will be harder because we'll have to also create like the basic attack state and all that stuff, which will, the patrol routine and all those. but I'll kind of just show why I like going this route for just like simple AI. It's not as smart as like a goal-oriented action programming AI, that an AI that uses goal-oriented action programming. Um, like this is very simple. Like there's a bunch of rules. If those rules are true, it's gonna do something, and if that's not true, it's just never gonna do it, and it's gonna do something else, or it's just gonna stay idle and all that stuff. In an RPG, it would feel a little bland if it was like this. Like if it loses its weapon and it can't attack you anymore because it doesn't have a weapon, like that's kind of weird. This isn't really meant to be that immersive with the monster type. I think it's just more of a monster does one thing and you have to learn what that monster does and how to go around it. But like the design will remain pretty consistent across what that monster does. Like that monster is not going to be incredibly smart and go pick up a sword that it's not using to attack you. Like it's just like not in the scope of this game. And it's not really necessary as well. Like the goal is to have a lot of monsters that you can tackle and handle, not have like, you know, one that you have to dodge around and serve as a puzzle. It's more of a game that you'll want to try to play a little bit more, you know, action and reckless rather than thought out and figuring all that stuff. Anyway. And it's kind of nice as well because the way it's set up, like the NPC renderer is for every NPCs, and then the AI movement is going to be for pretty much every NPC is going to rely on those. And then we'll have the brain, and that's going to have a bunch of extra little tweaks based on just the type of people it is. So we'll do another folder and name it monsters. Then we'll name that the dungeon. No. Then here we'll do C# script called skeleton. So the skeleton. We're gonna delete all of this and we're gonna make it inherit AI controller. Then we're gonna go, oh, my leg is going numb. That's not fun. There is kind of one thing that I want to add in here, and it's the fact that so first off here, region NPC rendering and hashtag and region here. One thing that I did want to add though is, and that's why I kind of wasn't saying anything and looking blankly so far, but right now, if you are there's a couple ways that the player can be detected. And I think it can be there's a couple ways that the skeleton can detect the player coming towards him. The first way is to just make it a distance check, go toward that character. If the player is under like a distance 5, then move towards the player. Or you can do it in a raycast. And I think that's what I want to do, where you do 2 check. I think what we'll do, because I don't want to use like a collider. Like I want to keep those range for very specific thing. I don't really want to rely on like colliders and trigger enter to do all that stuff. What I do want to do now is kind of put a field of view like angle. So here, like let's say this is our guy here. The first thing that we can do is make it so that like if the player comes anywhere near too close, like the skeleton will see it and just attack him. So we'll do that. We'll do like a you know what? Instead of doing an AI controller first, we're gonna do a monster controller. The monster controller. The monster controller is going to be on the AI controller, and the skeleton is going to be a monster controller. That's how we're going to do it. So in this monster controller, first thing we want is to go over here and not lose all the settings we just set. I really like the fact that it changes all the time. I feel like it adds a little something. Anyway, I'm kind of very zoning out today. I don't know why. I have a hard time concentrating. It's one of those days. We're gonna start him on the passive states. Actually, I think for the passive state, we'll do it in the AI controller first. And the reason is, what is the things that a, like, what might an NPC be doing when it's passive? It's going to move around to a location. Is going to stand and wait, maybe do an animation like randomly. But essentially it's going to either walk to a place or it's going to stand. So what we need is a set of places that it can walk to. If that set of place is, empty or whatever, like we're gonna do a path, we're gonna set a point here and a point here, then the character is here, he's gonna go here, then he's gonna go here, then he's gonna go back there, like we'll, 2 points. And if we don't want him to move, we'll just put no points and that will be it. So that's gonna be our passive routine, a patrol routine, or a passive routine. And yeah, I think it's kind of an important thing to do so that it's simpler for future stuff, to change. And then we'll also, like, the way the character moves won't be dictated by the AI, but by the seeker of it too, and we can add modifiers to that to make it round and to add points and all that stuff, all that good stuff. Yeah, you see, like, raycast modifier, simple smooth modifier, like all that stuff. You can probably make it simple smooth. But it's gonna be the same thing. Like you're gonna have, on enter, on exit, and that's just gonna be it. And then you're gonna have your basic states that creates something simple. It's not going to be a routine, it's going to be a passive state. It's just, and the AI controller is going to have a literal set of points I'm considering not even making it transform, but making it just, passive patrol positions. Passive patrol targets. Or I'm actually even going to make it vector 3s, because do we really want... I mean, it is... I don't know, I don't find it simpler to change stuff. But I guess it is, because you don't really ever know, so we'll just make it transforms. So it's monsters. We drag our player, and in monsters, we're gonna create an empty patrol points. And those patrol points, we'll have patrol 0, 1, essentially. We're actually going to make them patrol point segments, and the reason is that way we'll be able to track if that patrol point is being, targeted, and we won't have kind of overlapping characters that are trying to get to the same point and all that stuff. So our patrol point is just going to be a private AI controller occupying character, occupying AI. And I will do private void set occupants AI controller, no. Private void set occupant to an AI controller, new occupant, and the occupying AI is going to be equal to the new occupant. It's going to be pretty simple. We're going to link that here. Link that here. We're going to make sure we add the skeleton. Copy components. Oh, I can't compare. Damn it. Of course. So we've got 0.11, 0.75, 0.11, 0.75, 840, 120, 624, 840, 120, 624. Then our pelvis 1.3 randomized 9 2010.75, 9 2010.75. Passive patrol points, we're gonna have 1, and we're gonna have 2. 9 avatar, we're gonna randomize it. It's going to be this one and these 3, 4. The animation clip, this is 1, this is 3. The pelvis bone is this one. This is the getting up facing down, and this is the getting up facing up. All right. Okay, so at least now we have a new little occupant and it's all good. So AI controller, so our dead state is going to be this, and our patrol state, passive state is going to be new patrol, new passive state. A new passive state that is going to take this and the patrol points. Passive patrol targets. So in here we're gonna have private AI controller called the agent, and we're gonna have a bunch of patrol points called M patrol points. Private patrol points M next patrol points. All right, and then public passive states, taking an AI controller and taking a set of patrol points, setting the agent to be the AI and the patrol points to be the patrol points, as well as M next patrol point to be null. Then when we enter this state the first time, we are actually not going to do anything. You know what? We're going to do one thing. We're going to add here a private float delay start. It's going to make sense. So we're going to set delayed start to be equal to time.time delayed start time to be equal to time.time plus a random value we're not going to make it here, we're going to make it here. A random range between delayed start 0 and delayed start 1. Then in here real quick, private float delayed start passive delayed start range. Actually, we'll just do delayed start range. The reason why we do this here is because we want to make sure not everything is initialized at the same exact time, pretty much. And the chances of that happening are pretty low if we do something between 0 and 1. It isn't, you know, between 0 and 1, it's going to give us between, you know, 0 infinite zeros to, it's going to be random enough. It's not really going to be random, but whatever. Topic for another conversation. This is going to be to ensure not every passive state is started at the same time. Minimizes overlapping patrol point. Minimizes AI choosing the same over patrol point. Because if we all initialize them at the same time, yeah, I don't know if it's super necessary actually. It probably isn't. But that's a question. That's a bigger question. It's like, does it call? I mean, technically, you would call them one after the other one, but it's gonna be very minimal anyway. Anyway, you know what? Fuck it. Let's not do that. For now, we'll leave it like this, and we'll actually worry about it when we need to worry about it, which will be not now. So it is not very useful to do this now. Okay. So back to our passive states. On enter, we're gonna find I thought I made that public, no? No, I didn't. That explains. Set occupant, no. So, all right. So on exit, we're just going to clear this to make sure we don't continue going to it. Unity has utterly crashed right now. Like, it's not even funny. Kind of, as always, I feel like it's a recurring thing I say, but it feels weird how often this Unity thing crashes. And I just rebuilt my library folder and all that stuff, so that's a little infuriating. Anyway, in here, let's do a private void find next patrol point if m next patrol point is not equal to null, then we're gonna do m next patrol points dot, then we're gonna do this, and then we're gonna do equal null to just reset everything. Then we'll do, you know, for each bar patrol point in patrol points point in patrol points. What we'll also do is an m last patrol point equal m next patrol point. M target point, we'll call it. The reason why we're doing this is so that we don't always land on the same patrol point. So like we'll make sure that we have, you know, the last patrol point tied to the next patrol point. And actually I think, yeah, that's how we'll do it. So if points dot occupants not equal null and points dot occupant not equal this, continue. Not equal m agent, continue. If points equal m last patrol point, also continue. Otherwise m next patrol point, m target point is going to be equal to point, and we're going to be able to break here. All right, essentially it's going to look something like that. And I think we'll make this one, whatever, doesn't matter. Okay. So on enter, we're going to find next patrol point. Then on tick. If m target point not equal null, if m target point equal null, we'll just return. If m target points distance to target is going to be mAgent.rigidBody dot position m target points dot transform dot position if distance to target is greater than mAgent dot reached waypoint distance, then we are going to actually, how are we gonna do that? That's a good question. So essentially, in our movement scripts functions, we've got to look for path, and we got an at end of path. We have a looking for path, and we actually also want a public bool has path called m path to follow not equal null. So we're not going to do this. If m dot agent dot has path and m dot agent dot not looking for path. And m.agent also doesn't have, if it's not looking for a path, if it doesn't have a path, or if it reached the end of the path, essentially. So if it doesn't have a target or it's looking for how to get to the target, we're just going to stop the ticking for now. Otherwise, if it has, you know, and find next patrol point, here we're going to end up having to do m.agent.look for path. We're going to do, sorry, AI controller, look for path. So when we try to find the next patrol point, if we reach the end, if we don't have, so if we have one, we reset it. Otherwise, we all right. So if the agent has path, I'm also going to remove this AI here. Just gonna do it like this. Remove this. Remove this. We really don't need to make it static, I think. If we do, I'll redo it, but I honestly don't think we do. Oh damn, my magnets are sticking everywhere. So if we have a path to follow and we're not at the end of the path, we're gonna do this. Otherwise, we are going to essentially change and reset the path we're at. One of the things that I was kind of curious about is if there is a sort of if there is like a also I don't want this to be that big or that bright. Sorry about this. Is there in here a way to tell me when agent movements, multiple agent type, searching for path movement script? We got a path, but is there a way to like okay, it's fine. Essentially, if has path, we're gonna reset the path to follow is gonna be back to null, and the time at destination is going to be equal to 0. No. Time reach destination time. Let's do this. Reach destination time is going to be time.time. This reach destination time is going to go over there. Okay. And then in here, where not the movements, the state machine brain, we are going to do essentially So the reason why I'm changing this to from a protected virtual to a private is because I don't actually want the player to be able to get spawned and then instantly the AI are aggressive towards him. That just doesn't sound really fun to me. I'd rather start it with the passive and then let the player trigger a step Even if the step is like a 2 second delay and then it becomes aggressive, as long as there's like a little bit of time for like everything to land, the player to grab the controller and actually get to play after loading time or and all that stuff. I just think this should work. And then in here, if has passed and M agent reach destination end time dot time greater or equal to plus M agents dot delay delay at patrol, M delay at target, then we're going to do find next patrol point. Oh God, thank you for the follow. Just I was in the middle of figuring something out and the notification sound made me jump up. Thanks for the follow though, Nico Launch. That notification sound is loud, let me tell you. Not sure exactly how to modify them, but hey. Oh, damn it, sorry. I'll learn at some point. So in here, what we wanted to was also a simple, I'm not gonna make this a range because that's what we did in our previous game and it just felt messy. Like it felt like the characters were leaving at totally unpredictable times when you didn't want them to leave and all that stuff. It worked back then because that's what we wanted. We wanted kind of like a messy villager walking around, doing something, turning back, doing some other stuff. And the days were only 10 minutes, so we wanted some more movements. But right now, doing this and making like in a game where you want the player to traverse a dungeon, learn about how the monsters are, how to avoid them, how to tackle them, and how to beat them while having fun and also while fighting other players. If we were to make, in addition to that, the AI hard to understand, it would be a mess. An uncontrollable like mess. Like people wouldn't be able to. People would know. It would be like a really hard game to play too, because you wouldn't be able to really understand what the monsters are doing. So it would feel really random. So anyway, that's at least that's my thinking to do that. So here we'll do a delay at patrol point. Actually, you know what we're gonna call it? We're gonna call it passive repath delay. That's a bad one. Passive passive repath delay. Fuck it. Let's leave it like that. And then in here, we're gonna call it delay at target, the private float delay at target is going to be float delay at target and M delay at target equal delay at target plus M delay at target. Okay, so if we have a path, and we're just gonna call this delay and delay at patrol point. There you go, perfect. We're gonna link it back there, and so let's review a little bit. So when we start the game, we're gonna start with this guy in his passive states, and the delayed petroleum point is going to be 2 seconds. And he's going to start, he's going to have ragdoll on death. Okay. So, delayed patrol point should be all good. We set the states here, dead state, passive states. If we don't kind of want to redo the step every time here. I feel like there's going to be an issue. So get current states equal not equal to the dead states. And so essentially we're going to do this. We're going to switch to the dead states when our brain state is dead and when our current state is not the dead state. So essentially it's going to prevent dead states to transition back into itself. Granted, I don't think I needed to do that because I think in the simple state machine, the get transition stuff. No. If it's in any transition, it's going to look at any transition. If this brain state is dead, it's going to return this transition, which is going to mean that in here, we're going to have a transition. It's going to set that transition. When it sets the transition, it's going to call both on exit and on enter. And it's going to make it a little weird because the dead state on exit has a false trigger ragdoll, so it keeps triggering in back and forth and doing some weird physics stuff, and probably a horrible thing to do. So we'll do it like that. This is good for me. And then the other function is kind of the same thing, really. We could do it differently. How expensive is this? No. Let's just do it like this, not complicate things further. That way we'll just move forward. So in here, same thing. We're going to switch back to the passive state as soon as the brain state is passive, but the current state is not the passive states. So this should move us back and forth between the two of them. And then this is going to be the specific interactions that are going to dictate when the character goes from a passive state to an aggressive state. And here what I was saying is that we set the initial states like that, and we keep it private as well, so that the later iterations are always going to be doing the same thing and not going to have like a crazy thing. It's always going to start passive or dead and either come back from the dead as its own logic or transition to an aggressive state if it's a monster. And another thing we want to do is here, if M is not grounded and if the state, do we have a state on this thing, or is the state just for the player? No, we have a state here. So if our state is not equal to the full state, what will return is not equal to our blocked state. Because essentially what we have here, we have a default ragdoll and a block step. When it's a ragdoll, we'll still want to do this stuff. That state stuff. But when it's blocked, we won't want to continue doing this because it's probably just not supposed to be moving anymore. So if it's blocked, we return, otherwise we continue. I wonder what set last val. What does that do again? Triggers the ragdoll, right? I think we might just want to do this. Okay. So then what happens when we get our So when it ticks, it creates the current state tick. So if the current state is the passive state, it's going to go here. When we find the next patrol point, we're going to go here. Start path, on path found, path error, path to follow, blah, blah, blah. So when the path is here, and when once we calculate this, okay, so let's do that. We're going to change it a little bit. We'll make it if has path, then mbrain dot move else if it doesn't have a path and the time is greater than the reach destination time plus the delay target, then we'll change the path. So magent dot move AI. Move AI. This move, oh sorry, I think I yelled at that mic. Anyway, this move will take a spring, will check if we're on a spring trap. If we're on a spring trap, it will trigger it. If it doesn't trigger it, then it will calculate our movement. To calculate a movement, we need to make sure we have a path to go to, and we're not at the end of the path, otherwise there's no movement. And then we face the proper direction based on whatever look rotation we want to look at, which is either the last rotation or the rotation that, which is towards the last point, essentially. So that's that. Second thing we need to make sure is making sure we have the correct location for the patrol points. But you know what? For now, we'll put a patrol point here and a patrol point over there. And now let's see how it reacts. Okay, so it goes over there in a smooth little line. Oh, it got killed. It's actually pretty cool. It got killed because it got hit by the ragdoll. Alright, so there's another thing we need to do. If it turns into a ragdoll, we'll go back to the dead state. Let me just stop for 5 seconds because I'm getting a phone call right now. I'll be right back. All right, we're back. Sorry for this little intermission. Um, and also not for, I mean, I had a phone call that happens, but also sorry for making the weird Twitch with the overlays. For some reason, I couldn't get the proper scene working correctly. All right, so where are we at? We were at coming back from a ragdoll state, essentially. So in here, I think it's worth making it so that when we go into our ragdoll controller here, like look, when you go into your dead states, on enter, we trigger this ragdoll. And then in this ragdoll, we switch to state, okay? So now the question is, how do we make it so that when the controller switches to ragdoll, it also switches to, you know, the dead states? Trigger ragdoll on enter, and M agents is states not equal to ragdoll, then we're gonna trigger it no matter what. So like if he dies, we trigger it. Because there's a couple of ways to do it, but essentially, essentially we'll do it like this. You know what? If states equal ragdoll, or the brain state is the dead brain, then we do this. Actually, for readability, we'll make it this and this. So if the current state is not the dead state, and if the state is ragdoll or a brain state, then we transition back to dead. That's option 1. Option 2 is so when you are dead, this is kind of big, right? This is essentially what we want. So, and I'm saying this because when we have our dead states, if we are playing the death animation, that's that. If the spawn out, blah, blah, blah. So first off, it's going to be if delay before getting up, M delay before getting up, private float delay before getting up, right? So public float M underscore delay before getting up, private float M time when ragdoll movement stops. So on enter, this is going to become -1. If M time when ragdoll stop is under 0, M time when ragdoll stops equal time.time. Then if time.ragdoll stops plus delay before getting up, if if time is under or equal to greater or equal to the time when we stop plus the delay, then we're going to do M agent dot switch brain states to the passive. Ragdoll is the equivalent of our dead states return. So if we're not dead, we return. That way, when we change this state, even if it takes us a couple minutes to actually get out, a couple of frames to actually get out of this, or it takes to actually change Goldion exit and all that stuff, then I think we should be fine. So this will have the effect of, if we set this and this once, yeah, so that's what we'll do. Now we'll make the delay before getting up be 3 seconds. We're gonna save it. We're gonna go back out here. We're gonna watch this, and we're gonna play it and see what happens. So he's gonna run. He's gonna get hit. 1, 2, 3, 4. Gonna get up. I guess not. It's not gonna get up. Why is that? Is that the question? So, oh, you know why? It's because it's not taking right. Now it's a ragdoll, so it's not taking. Huh. So I guess the only way we won't tick is at the top. At the top. There we go. The only way we won't tick, honestly, is if it's not grounded. No, it is sticking. So wait, why does the embrate? It is sticking. So what's going on? Fixed update. Maybe it's just not grounded. True. True. Brain tick. Transition. Transition not equal null. The state to the dead state. Why is that true? Oh, I know what I did wrong. Here, I made the dead state here. It shouldn't be the dead state. It should be the passive state. Any transition to the passive state is happening because of that. Now it should work better. And also this thing here, passive spectral, dead state, dead state, dead state, dead state here. And when ragdoll movement stops, should become under 0 and yeah. And we're gonna change how we're doing it because we're gonna make it be so that at the bottom here we get a private bool chain check get up. Nope, I mistyped. Check get up. If m delay before getting up under 0, return false, otherwise return true here, otherwise return false. Wait. No, return true as well here, I think. I made it so much more complicated. No, this is just, it's not simplifying anything and it's just making it more harder. So greater or equal to 0. If the delay before getting up is greater than 0, then we're gonna get up and return. Alright, let's try it again. One thing that I wanted to check is how can I make it so that they'll explode? Well, not the pelvis, obviously, but yeah, that joint, for example. Like, how can I make it so that they break apart or they don't stay connected? You know what I mean? I will figure it out later. So right now, let me kind of relook into this a little bit because I'm a little confused. First off, this guy here follow through continued velocity multiplier. It's gonna make it a little bit. Time to lower bones is gonna be 1. Delay before getting up is gonna be 4. So let's try it again. We go, kill, and we go back up. Yeah, why does it move so much? Like, it's blocked right now. He still moves. The fact that he does little movements when he's on the floor and tries to move up is pretty funny, if you're being very honest. This should make it better. What the hell? Why is it even moving when it's first sticking is what I don't understand too. I mean, figure it out, but it just doesn't really make a lot of sense. Oh, because it's not the pelvis, it's the ragdoll velocity. So the last velocity magnitude is because it's the pelvis bone's position. How do I do it on the player then? I feel like on the player I pretty much only do it like movements, get up from ragdoll. First collider, that's what I do. Hmm. I think that should work. I mean, I just have to fix this, obviously, but I think that should work. Oh, I know what to do. To keep it still looking nice, we're gonna keep those here. Do this, do this. Then here we're gonna do and then here the last velocity magnitude is gonna go here. All right, let's try that again. come on. Why is everything... Oh boy. I mean, it doesn't even really make sense that it just... Yeah, like, why is it triggering? All right, 312 makes it a little bit better. It's basically divided by 2. Basically, the strength was too high, the damper was also too high, so you would also always go further. So you would just end up oscillating. So that's problem number 1. Now, problem number 2 is figuring out what's making it get up so fast. Alright, I just want to figure out, so doing this is just mainly going to get me the alright, so what does it do that? The number one thing that I want to fix is figuring out why the move AI still moves when I here. Let's wait until it triggers. Okay. Of course, now we're gonna have an issue. The tick. The state is not equal to ragdoll, so we return. So why? Aha, I got you now. What is going on? Why are you moving right now? Right this second. We're gonna put a breakpoint here. And we're gonna step forward. State is default. So why did the state become default is also the question. I think its state is actually never changed because we moved to dead. I think that's maybe what's happening, which would be fair. It's because here, trigger ragdoll. Does it change the state though, is the question. State not equal awake, that's the player, so I mean that can't be every use. No, that's the yeah, switch ragdoll state. It should go on to be I think this guy is gonna go move a little slower. Yeah, there you go. State becomes ragdoll. So what is... Oh, because I didn't check the bug. That's why. Oh, it's not ever doing it because it's changing the state by itself. That's why it's confusing to me. State, this thing. Darn. Alright, he's gonna go move slower. Oh, shit, I missed it. Let's move him 5. Alright, so she's moving back. It's instantly going to blocked. Because of the tick, it's going to block because of this, and this is being triggered because of this. This is being triggered in itself because of this. Because the transition is not equal to null. State equal ragdoll, okay. The brain state isn't changing. Why? What's going on with this thing? My God. This is what I don't like about making those systems. There's a weird issue going on right now that I swear once I find it, I'm gonna feel so dumb. The brain state, switch brain state. Here. Is it because you're triggering the ragdoll? It's going to ragdoll because it's going to ragdoll. It's triggering the dead state, but it's still passive, so it's going back to the passive. Then it's still ragdoll, so it's going back to. So it's still but it's still passive, so it's going back to the passive, so it's triggering the on exit, so it's getting up from it. So I think I got it. I'm gonna be right there, handle the dog, and then I will fix that in 5 seconds. All right, so where were we? We were here. So what happens is on enter, before we do anything, if m agents dot brain state, we're gonna switch the brain state to just the dead one. Doing this here too, because this state can be triggered when going ragdoll without how do you type necessarily? Necessarily like that? Yeah, looks like it. Necessarily being in the dead brain state, like for traps. Essentially to handle going dead when triggering the ragdoll externally. This should fix it. Well, should fix the first issue. The second issue won't be fixed right away, but maybe it will fix the second issue as well. All right, that was much better. All right, now the question is, what the hell is it doing? Oh, you need to recalculate the path. You need to recalculate the path. Straight one more time. It's going over there, getting shot at, going up. Then it's retargeting the path from here, which is where the rigid body was shot at. But this is still over there. So that's because when it's doing the passive routine, the passive state here, on enter find next patrol point, but maybe we don't want to find the next patrol point. So essentially find next patrol point. I think I recalculated a little bit too early. Two, three, those four. On enter. Target point. Fuck, that's true. Maybe we don't reset the target point on exit. Now we should. We should reset it. But maybe we don't set it to no. No, we should reset it. Find next patrol point. See where it is? It's right there. So it's before the ragdoll is triggered. Back. That's actually interesting. So essentially, the AI controller is calculate the spring force is still here. Then it's sticking, and when it's sticking, it does this. It does, sorry, it does, if there's a transition defined, and there is, because now it does the current state on exit, which current state on exit would be the dead state, where the trigger ragdoll becomes false, changing state to ragdoll. I don't really know. I'm not really sure why it's acting like that right now. Hits, goes ragdoll. This is going ragdoll. And the passive state has not been entered yet. State still becomes blocked. So the state becomes blocked now, but we are going to rotate, and only after we rotate it, we are setting back. Forward pelvis, original pelvis position, transform. That position becomes equal to pelvis. Yeah. So replace the position. You lerp. Then you do this. You find the next patrol point, and then you calculate the path to this point, which is look for path to patrol point 2. And when you look for path, you take the rigid body dot position, which is 102.93.087 negative 0.85. Then the position. (102) (-2). Where is 102? (-2, (-3). That's, yeah. That's clearly an issue. That was around there, right? So that's what the issue is. It's calculating the position. So let's just do from transform. That's probably because the rigid body position doesn't get updated until much later, or until like at least a frame after, I think. So we'll just do the position from the transform on. See how alright, it falls. And it recalculates it. Gets up. Alright, and now it just doesn't know how to recalculate it though. Because now it's here. And he can't get up. Help. I have fallen and I cannot get up. Now he's stuck here because the tick of this is that he has a pass that he doesn't have a pass. 98.7, negative 3.1, negative 4.5. 98.7, negative 3.1, negative 4.5. -7, negative 3.1, negative 4.5. So it's the right position, that's for sure. And he can't get up because the stairs are, I think, mesh colliders instead of just being a ramp. And this is why stairs are ramps. Well, this is not why stairs are ramps, but it makes it a lot more simple. This is why stairs should be ramps, is what I said. How high a step can be while still allowing the AI to go up, down it. A 0 indicates infinity. This affects, for example, how the graph is generated around ledges and stairs. Okay. Oh, okay, I get it now. First off, everything crashed or something? No. Sure. Alright, I get it. Now he should be able to go up it. What the fuck? What the actual F is going on that guy? Alright, so that step is a little bit too high. That's okay, because now we can just understand how they make it. So essentially, A star manager scan does it like that. You definitely shouldn't be able to go from third step up. That's definitely going to cause issues. So let's just do divided by 2. Enter and scan. Yeah, that should work a little bit better. Right? That is it. That one's definitely better. Except I don't cut corners. Two, 3, 4, 5, 6, 7, 8, 9, 10. That's how you know there's an issue now. What the fuck is going on? because I'm not recalculating the point here. So essentially that change we did before was pretty much useless, right? Okay. Let's see how he handles it now. It was relatively decent handling of it. Okay. Now let's see how he does. Okay. This is where there's an issue. The fuck? Is it because this needs to be way higher? No. I'm suspecting it is because of the look rotation of this guy and where it's facing, and I'm suspecting it's facing up. How do I know? So it's gonna... Oh, I know why. I know why. So essentially what happens is, in our A-star movement here, when we calculate the movement here, the lookout rotation is the movement direction. But it shouldn't be. The movement direction is where we're gonna move, that's fine. But we want a rotation to face, direction to face, and here we want the movement direction, but then we want the direction to face dot y equal to the rigid body dot position dot y, and then we want to use the direction to face here. And yeah, I think that's it. So he's staying up. Oh. He went down. Let's see how he takes the stairs. He's still up. Fuck. So as we're already at almost 1,000 lines for this thing. So this is the movement. No, this is the jump. This is the movement here. Face proper direction. Transform that position. Now why? Exactly. Oh, you know what? No. Look at rotation. So the look at rotation, when you put in your movement, becomes the input direction. The input direction forward relative input. Wait a minute. Input dot y times forward. Can I try something? Can I do if debug dot draw ray I don't know, the transform the position in the forward relative input in Gaussian. So I'm just curious, what's going on with this joystick, because when I move slightly it stays up, and the moment I move too far it doesn't, it's not as smooth as I'd hope it would be. So let's just do this and do gizmo. Oh god, restore manager, this is turned off. Okay, all right, so essentially what is it's either straight it doesn't take a scaling option in it. Straight, all right, straight, it's plus. It doesn't take, so that's why. Okay, Um. Okay. Okay. So back to this. This thing. Can I make it? First of all, why is he moving like up like that? Huh. A little troubled as to why this is going that way right now. Get shot. Go back up. Okay, and then... Oh, look at that. Look at that. Standing up. Okay, he's getting real close to the wall though. It's kind of smart. Alright, so it fixed it. So now, was it this or the other one? Is the question. Was it because it was rigid position on Y and it was a little bit higher up? Or was it because it was something else? Like, now that's the question that I'm asking myself. I love seeing him fly out, honestly. Boo. A real skeleton. What did it say? Okay, so it was this because it was 0. So we just really don't want to look up. Could I make it this dot transformed? No. Let's just leave it at 0. We don't want to look up. Right? We want to stay at a level with our weird legs doing big ass steps. Big old steps. Sure, I mean, it works for me. I would say maybe it would benefit from having a little stronger force here. Like if it's 9,000, it's gonna go up with high. We don't want it quite there. We want it more like 1,000, I think. Look at that skeleton going for it. Is he gonna make it in slow motion? He passes this one. Oh, he doesn't. Alright, how does he get hit though? Oh, he gets hit like right before it. But because he's a skeleton, he totally explodes. And that I find kind of cool. I wish I could just leave the bones not... You know, like how, like, yeah, now he explodes. All the arms are gone. But they kind of return... Oh, and he falls up the stairs pretty much. Then 1, 2, 3, 4. He's gonna get back up. And then he's gonna try to go back up. All right, solid. All right. Now, we paused it. The poor guy. Now that we've got this thing, I'm going to make it a prefab and push so that we don't lose all our work. So we'll do a folder called monsters, and we'll name this that thing an original prefab, and we'll name it prefab monster skeleton. P monster skeleton 01. And updated files, corrected not being able to pick up items, added control to controllers, I'll say gamepads, made a skeleton with passive and dead behaviors, updated files, corrected not being able to pick up items. What else did we do? Fixed a star manager step height to allow NPCs to climb stairs. Modified and did the skeleton pretty much. Yeah, I mean, I think that's good. It's a pretty good amount of changes. Hello. Sorry, I was into my my coding stuff and I didn't realize. Oh, and part 2, because I always forget to check at least one prefab. Okay, that was pretty cool. I don't know if you oh yeah, it's pretty funny. I was speaking aloud, so but I feel like it'd be cool to have the each little skeletons of the guy like stay not connected. I don't know how I would do that right now, but if I would keep them like not connected, it'd be kind of fun to have like an arm flown up all the way across the corridor, and you would see like the arms slowly move back towards the position when it starts to reanimate. So it'd be pretty funny. Or like the skull is like by itself and you can see like slightly move on the ground and then the skeleton go back up. Could be kind of fun to make it like that. Right now it's very bare, but that would be, I feel like that'd be pretty fun. Or at least a cool detail. Let me clean up this too, because I know someone, Tiago, who does not like when I don't clear my debug logs, and I understand. It's kind of annoying to see it everywhere. Sorry, I received my new I received some new like Warhammer models that I've been looking at, and I've been building this one up, which is pretty cool. There's like a little station. I really like the amount of details. Like, speaking of details, I find the how much details they put in their models to be really cool. There's a lot of stuff. Like, there's a little pad. Oh, close up. It's like this little thing. But if you look behind, there's like two stations. There's one here where you can place one guy, like here. It's weird, but basically like that. And then there's that way he controls the little panel in the back, and then there's a little seat too. I just found the you know, it's just plastic, but the amount of like care put into it is pretty cool. And this one is old, I think, because they don't like, yeah, some of them are really old. There's this guy too. That was a lot of fun modeling. It's gonna be hard to paint, but that's cool. So the good news is now that we have an actual AI controller that works on two states, it can patrol and it can die. It already means we have a lot of the like tools to create simple movements in like a village or something. We'll need to like do a lot more work on it, but there's a base that works, and now we just got to figure out how to make the monsters variant attack the player. So we finished the AI controller, and now we're on the monster controller. So first, I think we want something like a header, the player detection. In here, this was kind of like what I was talking about really early before we were having all those take distance. Then serialized field, private float. How do you call the angle at which the character can see the... I have it right there. Oh, it's gonna bother me so much. It's in settings, line of sight. Thank you. No, not line of... Is it line of sight? Is that the angle? Is it the... Yeah, fuck it. Line of sight. I think that's what I meant. Yeah, thank you. Line of sight and line of sight. I'll do line of sight angle and line of sight distance, because they're essentially the same thing, and that works. Line of sight angle and line of sight distance. So essentially, how will our monsters detect the player? They'll detect it, him or her or it or they, by so you're gonna have a distance around the character that you can't escape. So like if you get so close to the character, to the skeleton, that you can, like, it can turn around and slap you, that, you know, you deserve to get slapped by the skeleton. that's kind of a short one. That's gonna be probably, you know, maybe 1.25. It's really gonna like mean like you need to be getting close. Let's make it 2. 2 means that basically behind it, if he's here, where was he? He's at 2.5, -2 right now. Okay. That means that you would need to be here. Once you reach here, he'll detect you automatically if he's here. It's basically 2 tiles. Oh, that's nice. 1, 2. Oh, thank God. We could probably tweak it later on, make it like 2.5. Something like that. But for now, the 2 is fine. That's basically going to be the distance where you can't escape it. Then the line of sight is going to be the angle of how much they see. Like, let's say the line of sight is like 45 degrees, so it's going to be like something like this, right? And if the line of sight is 180 degrees, it's going to be all in front, and if it's 360 degrees, it's going to be all around. You get the gist of it. Granted, I don't know if we'll calculate it from the forward vector to the edge, or if we'll calculate it, you know, like, I think it'll probably be that. So it'll probably be like 90 degrees will be up to here, 45 will be up to here, and then 180 will be up to here. I think that's more like how it's going to work out. That's the angle. So for now we'll start at 60, which should make it, actually we'll start at 45, which means it's going to go like probably here. 45 degrees or something like this. Which covers the bridge, and essentially that's it. And then the line of sight distance is going to be, you know, pretty self-explanatory, is going to be how far the raycast is. And maybe that will make it a little, maybe that will be, you know, like 1, 2, 3, 4, 5, 6, 7, 8, 9, you know, maybe 12, maybe like, or maybe 14, 2 hammers worth. Let's do 15 because I like round numbers. Now, it's going to be in our fixed update right now. We're doing our movements and then we're stopping. In our monster controller, we want to do our movements and then we want to do our like player detection stuff. So up in here, we'll do an override fixed update with the base.fixed update, and after it, we'll do our like, you know, detect player. Actually, if we do it after, it might be a little sluggish. If we do it before, at least it's going to be a little bit more snappy. But if we do it after, it will wait a frame. It'll give it more time to go and hide. I think we'll leave it like that. So detect players. Then in here, that's going to be our region for player detection. And then we're going to do hashtag end region here. So here, what we're going to do is a protected virtual in case we need to actually protected void detect players. That's going to be pretty simple. If state not equal default, we're going to just not do anything. Otherwise, for each var player in game manager dot instance dot player manager dot, I think we'll do like a total player stuff. Right now we have our player manager here, right? And then in our player manager we have our local players and our total players. Essentially public static, actually no, we'll just do local players for now. Local players. I don't know, I made it a static thing. Alright, great. So this is our local players. I'm removing this because I don't actually know how we're gonna tackle if we ever do an online thing. If we don't, it's gonna be kind of depending on what kind of support and interest this game gets. But it will be a problem we tackle when we get to it. For now, we'll just this is the game that runs locally. And we'll have to do stuff afterwards to sync up all this thing online, and that will be a lot of work, but we'll get to it when we get to it. All right, so for each of these we're gonna do a if caught player then we're going to switch the states to we're going to do switch brain state to aggressive. So we don't try to detect players. We will only detect players when we are not aggressive and, you know, not blocked or not in ragdoll. So if we catch the player, switch the brain to aggressive, and you can exit out of this function. And here we'll also do like a little private last player caught and out last player caught. It's going to be something like this. So essentially this is a protected bool function called caught player that will return a player like this. Oh, my back cracked pretty bad. Caught player. So if Oh, shit. Actually, this just needs to be player here. Player to check here. And then here is going to be last record equal player. If player dot value equal no, continue. Otherwise, player dot value. Player dot value. Okay. So we're gonna have first the auto check. So this is going to be quite literally if rigid body dot position Alright, so this is our distance to the player. So if our distance to the player is strictly under the auto detected distance, then return true. Hello. Thank you for the follow. I still I don't know if you saw it on the camera, but every time the notification pops up, it is so loud for me for some reason. It kind of scares me. This is, so we're doing a co-op dungeon crawler game that's a mix between Lethal Company and Party Animals, pretty much. So you essentially the principle is that it's not announced yet, and it's a prototype that I will get to pitch next week. But essentially, you enter those dungeons with your friends, and you have to compete against them, and sometimes with them. You have to find that balance with your friends, but at the end of the day, you compete with your friends to be the adventure that gets the most loot out of the dungeon, and with that, then you can return to your guild and then progress and all that stuff. But yeah, it's essentially a combination between Lethal Company and Party Animals. And then today I've been working mainly on making a simple AI that can travel around and catch the player, travel against certain patrol, like you can patrol around, all that stuff. And right now I'm working on making the skeleton that is back here. Come on, Unity. There's a skeleton like here, this guy. So those are characters that will change. We'll redo that when the time is right. For now, we're just testing stuff, but this is our skeleton, and I'm working on making him detect the player when the player gets in his line of sight, and Now then he's gonna chase attack. Just a pretty simple AI currently. And right now what we have is this little guy who runs around under those big hammers because we were testing how the ragdoll is, and hopefully he'll get hit at some point. It's been very lucky. There we go. So you see it get hit, and then he'll slowly get up and then climb up the stairs here and try to make it to his target point that's back there. Then he makes it, and then he'll come back, and then you can see it's very bright, but maybe if I turn this off, you can kind of see the green light is where the path that our skeleton wants to take to go to his point. Also, maybe now that it works, something that I forgot to add again, maybe we can try to make him a little bit more smooth. Like right now, he's not super smooth. When he walks, you can see the in the path, the squares get either straight through the middle or cut into half if he needs to do turns, or you know, and that's that's how the algorithm works, but it doesn't make it super smooth. So I think if we add this guy up here, it will end up making, see now it's a lot straighter, and when he has to change and rearrange himself, he doesn't do like a huge corner, he does like a bend around. The question is, I think it may cause issues here. So if you look at him now, he's getting up and he's going to try to climb up this spot here, and I hope he doesn't get caught. Yeah, see, he kind of gets caught a little bit. So, is there an issue? Max segment length, strength, determines how much smoothing to apply in each, produces the nicest looking curves. I mean, let's try to move it down a little bit and see what he does. It's definitely, does this end up making it more or less smooth? No, it's less smooth. And if it's less, I'm hoping maybe 0 will end up making it so that it's just like there's nothing. Yeah, essentially that's it. I'm surprised he still didn't get hit by the hammers. Oh, there we go. There we go. Gets shot at. He gets off. And then he's gonna go up. Right. I think we might want to reduce the step height slightly to a 0.65 is what I'm guessing. If we reduce to a 0.65, then I think we can keep that a 0.5 and have something that is pretty smooth. Yeah, so here there's only one overlap, so he should be able to go without being gets off. Oh wait, before he comes back up. Where is it? This guy here, the root is gonna go over into that corner. Let's see what he does now. Ooh, Ooh, that's cut short. Yeah, of course he's gonna get stuck here. So we'll make it slightly less smooth, and the max segment length iteration will make it 1. This is 0.4. What is this one? The length of the segment in the smooth path when using uniform length. High value leads rough path, and low value yields very smooth path, but it is slower. Okay, so let's instead make it 3. Iterations, number of times to apply smoothing, only 1. It's fine, I think. Oh, no, I think we want 1. Yeah, this is what we want. We want 1 so that he actually moves. Oof. That skeleton got beat up today. There's something pretty satisfying I find about watching an AI move on the screen by itself. Just seeing what it does. He needed a long break today. He was like down on those stairs for a long time. Yeah. I think we'll do that so that it's a little smooth, but not fully. So where's that guy? It's over there. Yeah, a little smooth, but not, you know, too much. I still think that we probably have enough room up here to modify this slightly more. To maybe a 0.6. What is the value between... I think we'll just remove the smoothing and make it really, really light. 0.05. I think we'll just smooth type, offset, simple, curved, non-uniform. Surprised to like I'm curious how those other modifiers work. So Alright, come on, buddy. Run. Alright, let's speed this up a bit and move the pelvis. Move this guy back in here. Yeah, you know what? This one is a little rough, but it works nicely. They still try to get up over this thing here, and I kind of wish it wasn't like that. But all right, I think I'm gonna go take a short break and go eat because I'm getting hungry. And we are supposed. I'm supposed to. We're almost at the end of it today. Anyway, it's 7 p.m. Um, yeah, I mean, kind of a lot of stuff happening today. I am going to. What is this offset simple iteration offset point to apply in each smoothing iteration when using offset? Bezier. I don't really think this is super necessary anyway. I feel like yeah, is it? Like this is what the player will see. He goes down. Let's pause. All I want to make sure is that, you know, the smooth doesn't make anything worse, or, you know, like it just keeps it the same. And I think the issue, sorry, I hit the mic too, but I think the issue really isn't the step itself. It's like this thing right there, and like why it's acting like this. I'm thinking if we make it lower, then there's no really much more step you can have. And if you make it, you know, like that, so if it's 0.5, it works better, but 0.55 still kind of the same, honestly. So 0.6, and then once you have 0.6, then you have this one too. Probably because this floor, this is a wall. I mean, the other option, honestly, is to just make it a convex, right? Like, if it's convex, if all these, right, this thing, first of all, that's a wall. This thing, that's also a wall. This thing is also a wall. So it's really this one and this one that we want. They're both ground, we're both making them convex, and I think it should work. And now if you do this, and I think if you make it 0.5, hopefully, you know, I can't figure out if it's better or not. So it was like this, right? Before, and then essentially there is basically a half and then a full. So yeah, it still kind of does it. And if we do 0.5, And if we do 0.4, okay. The only issue is those underneath. It should not be there. That's because they're connected. So I think essentially we more want it like this. Yeah. All right. So I'm just gonna angle check written false if not in angular range. I don't know. All right, and then to finish, raycast to player to make sure it's not covered by a wall or something, by a wall. And this will have caught the player. Once we catch the player, we can do a bunch of stuff, change it to aggressive, as we say here. It detects the player. Once it changes it to aggressive, this is where we'll be able to do our little wake. So like here, right? And our AI states it will change to aggressive, and when we change to aggressive, we'll be able to do this stuff. And basically for aggressive, I'm thinking we'll probably have a path calculator, an attack, and that's it. The basic aggressive is going to be path or something else. Okay, well, thank you for hanging out with me for a bit. I will go eat, and I will see you guys. I probably won't be streaming next week because of the GDC and all that stuff, but I'll see you afterwards. So yeah, have a good one.